Hello. Good evening, all of you. Good evening for live classes. So look at once the board. Still is there. Yes, others. So look at me. Is that clear? Once confirm to me. Once confirm to me. The audio and video is clear. Once confirm to me. Audio and video is clear. Yes, brother. Yes, brother. We'll discuss the relation between the KC and KP. Okay, am I clear? So audio is clear. The video is clear. So look at my dear students. So audio and video is clear. So now we are going to discuss the relation between yes. Right. So look at relation between the KC and KP that we have to discuss. For any equilibrium reaction, for example, I'm taking that is N2 plus 3H2 gives rise to 2NH3. Consider this is one of the equilibrium reaction. So N2 is a gas, then hydrogen is also gas, then ammonia also gas. Clear? Then in case if you want to write Kc, nothing but equilibrium constant in terms of concentration. So equilibrium constant in terms of concentration, what you have to write? Products concentration divided by reactants concentration. What is the product concentration? Ammonia will be there. So ammonia, then stoichiometric coefficient that you have to take it as power. Then divided by, then both, N2 concentration, then the stoichiometric coefficient only one is there, so need not to mention there. Then hydrogen, so hydrogen, the stoichiometric coefficient 3 is there. This is actually the Kc. So remember the Kc we have to express like this. Clear, right? So look at my dear students. So then the Kp, in case if you want to express Kp, it is equals to, then pressure, all these are gases, sir. All these are gases. So partial pressure we have to take. Partial pressure of ammonia Sir, stoichiometric coefficient power 2 divided by partial pressure of N2 into partial pressure of H2 power what we have to take. Then what is the stoichiometric coefficient is there that we have to take as a power. Clear? So next the Kc and Kp both we have seen how to express the Kc and Kp. Sir, Kc, see nothing but concentration. In terms of concentration, కాన్సంట్రేషన్ ని ఎలా ఎక్స్ప్రెస్ చేస్తా ఉన్నామంటే స్క్వేర్ బ్రాకెట్ లో ఎక్స్ప్రెస్ చేస్తా ఉన్నాము. సో స్క్వేర్ బ్రాకెట్, so nothing but the concentration we are expressing in the square bracket, that is also called as active mass. Active mass, that is also called as active mass. So active mass nothing but the number of moles divided by volume, that is nothing but molarity. We know that, right? Yes. So look at the Kc and Kp relation, both we are taken. Kc and Kp relation. Clear, my dear students? Yes. So now I am writing the partial pressure of each term. Sir, in case if you want to take the partial pressure of each term. So before going to write the partial pressure of each term, so we know that PV equals to nRT, right? PV equals to nRT. So then pressure is required means pressure equals to number of moles divided by volume into RT. Number of moles divided by volume into RT. Then number of moles divided by volume, what I told, active mass. Active mass nothing but the concentration. So pressure, it is equals to active mass or concentration into RT we can take. So all these gaseous terms, in case if you write in the partial pressures, so look at partial pressure of N2, in case if you want to write partial pressure of N2. So concentration of N2 into RT, that is equals to concentration of N2 into RT. Clear? Understand? Then partial pressure of hydrogen, then partial pressure of hydrogen equals to then H2, concentration of H2 into RT. Clear? Understand? Yes. The next, sir, partial pressure of ammonia, NH3, partial pressure of ammonia, that is NH3 into RT, that you have to take. Okay, understand, my dear students? Then partial pressures are we are taken. So all these partial pressures in the Kp when it is substitute. So Kp term lo substitute cheste. So partial pressure of ammonia is there. Partial pressure of ammonia, what will be there? So NH3 concentration, so into RT whole to the power divided by then partial pressure of N2, what will be there? So N2 concentration into RT. Clear? Then into H2 concentration into RT whole to the power cube. Yes, understand all of you? Right. Next, what we have to take? Then here concentration terms, what will be there? All that we can separate it. Sir, NH3 concentration, so whole to the power square, then divided by, sir, N2, then concentration into H2, then whole to the power cube. Then the remaining terms, what will be there? R and T, right? So RT whole to the power 2 divided by then RT whole to the power, look at here 1, then here 3, total 4 we can take. Clear? Understand? So then what we can take? So this term totally we call it is, that is Kc, right? So look at Kc will be, what will be there? Kc, what will be there? Kc, what will be there? So NH3 square divided by N2 into H2 power cube. So that is NH3 taken power, then divided by N2 into H2 taken cube. Right? So then the place of totally we call it as Kc, then into RT whole to the power 2 minus 4. So 2 minus 4, it is actually the delta n value. Delta n equals to what we can take? The number of moles of products minus the number of moles of reactants, right? So number of moles of products, gaseous products, these are, remember, gaseous products and gaseous reactants. The number of moles of gaseous products, what you can take, that is 2. Then gaseous reactants minus 4. Then you can get minus 2. So we can say in the place of minus 2, we can take this, that is delta n value. So in the place of this, that you can take Kc into RT power delta n. Kc into RT power delta n. That is what? So Kp equals to Kc into RT power delta n, right? So Kp equals to Kc into RT power delta n, right? Yes, this is the relation between the Kc and Kp. Kc nothing but equilibrium constant in terms of concentration. Then Kp nothing but equilibrium constant in terms of pressure. Then delta n nothing but number of moles of products minus number of moles of reactants for any reaction, any equilibrium reaction that we have to take. Yes. So next, so based on this, what type of questions they're asking in the previous examination, that is in the JEE Mains or in the NEET or EAPCET examination, that we have to take. So what type of questions they're asking, that we have to discuss now. So what is the relation between Kc and Kp? What is the relation between Kc and Kp? Kp equals to Kc into RT power delta n. Kp equals to Kc into RT power delta n, right? Clear? So remember here delta n value, in case if you got 0, delta n value 0, anything power 0 equals to 1. So that the relation in between the Kp and Kc, Kp equals to Kc. ఎప్పుడు డెల్టా n వాల్యూ 0 అయినప్పుడు Kp ఈక్వల్స్ టు Kc అవుతుంది. Then next one, sir, in case delta n value in case if you got positive, so positive, Kp is greater than that of Kc. Kp is greater than that of Kc. Then in case delta n value if we got negative, then Kp is less than that of Kc. Kp is less than that of Kc. Based on this relation, they will ask questions, so that we have to discuss now. Right. కదా నాదే. Right. So look at all of you. This is the relation between Kc and Kp. So next, what are the problems are there that we'll discuss? What are the problems are there that we'll discuss now? So look at the problem, relation between Kc and Kp. Look at the problem. Then problem number one, based on the relation between Kc and Kp. Sir, at T temperature kelvins, Kc value for the reaction, Kc value for the reaction, Kc value for the reaction, 2NH3, 2NH3, sorry. So 1 by 3 into N2 plus H2 gives rise to 2 by 3 into NH3. So all these are mentioned as gases here. Mentioned as gases. Then is 50. Is 50. Then the Kc value for the reaction. Then the Kc value for the reaction. Kc value for the reaction, that is 2NH3 gives rise to N2 plus 3H2 at the same temperature is this is the problem. So look at the question or look at the options, all of you. Then 4 into 10 to the power of minus 6. Then B, 8 into 10 to the power of minus 6. Then C, 6 into 10 to the power of minus 6. Then D, then 8 into 10 to the power of minus 3. So these are the problems. Look at my dear students. So this is the first one of the equation is given. So for this equation, equilibrium constant Kc is given 50, right? So what is the equation is given? So 1 by 3 into N2 plus H2, then gives rise to 2 by 3 into NH3. 2 by 3 into NH3. So look at here, the Kc values they are mentioned, that is 50. So now the one more equation is mentioned, 2NH3 gives rise to N2 plus 3H2. So what happens there? The same equation, when it is multiplied with 3, then reverse the reaction. So 2NH3 gives rise to N2 plus 3H2. N2 plus 3H2, they are mentioned like this. Clear? N2 plus 3H2. Sir, here what is the Kc value? They are asking question. What is the Kc value? At that time, how to do it, the Kc, it is equals to, sir, once the reaction is reversed, so then the Kc value we have to take 1 divided by 50. Then even this reaction we got by the multiplication of 3, entire the equation. So once in case if it is multiplied with 3 cancel, then we can get N2. Then here when it is multiplied with 3H2. When it is multiplied with 3 cancel, then you can get 2, right? So now, so whatever the number we are multiplied with the above equation, that number you have to take it as power 3. Clear, all of you? Right. So now, so 1 by 50, you can get it is 0.02. 0.02, that we can take it as power 3. Right. So 0.02, we can take it as 2 into 10 to the power of minus 2 whole power 3. Then 8 into 10 to the power of minus 6. So 8 into 10 to the power of minus 6 is the answer. So note the question, all of you. So this question is given. So this question is given in the 2023. So note the question, all of you. So in the EAP set examination, they are given this equation. Yes, note down the question, all of you. We'll discuss one more. Yes, note down the question. Yes, look at. So next question we'll do. Next question. Next question. Yes, look at the question number 2. That is, for the formation of ammonia gas, question number 2, for the formation of ammonia gas from its constituent elements, constituent elements, the Kp divided by Kc is, this is the question actually. So this is given in the 2022, then July 18th, the question is given. That is in the EAPCET examination. Sir, options are given RT, then option B 1 divided by RT power 2, then option C 1 divided by square root of RT, then D, then that is equals to 1. So look at the question carefully. Observe the question carefully. So here the formation of ammonia gas from its constituent elements, that is we call Haber's process, right? So Haber's process, what will be there? So N2 plus 3H2 gives rise to 2NH3. This is the formula, right? This is the equation. N2 plus 3H2 gives rise to 2NH3. Okay. So this relation between the Kp and Kc, how to note it? The Kp equals to then Kc into RT power delta N have to take. So what is the delta N value, man? What is the delta N value for this equation? So delta N equals to number of moles of products minus number of moles of reactants, right? Number of moles of products, how many are there? 2. The number of moles of reactants, how many are there? 4. So 2 minus 4, you can get minus 2. So in the place of this, that is Kp equals to then Kc into RT power minus 2 you can write. Yes, understand all of you, right? Then Kp divided by Kc equals to Kp divided by Kc equals to what will be there? So RT power minus 2 will be there. So that we can write 1 divided by RT whole to the power. Clear all of you? So this is answer actually. So that we can take it as B. So Kp divided by Kc equals to 1 divided by RT whole to the power 2. Okay. So note this equation. We'll discuss one more. Note this equation. Next question we'll see. Next question all of you. The question number 3. Question number 3, the relation between the Kc and Kp. Yes, look at my dear students. Don't deviate. Don't deviate. The equilibrium constant for the reaction is equilibrium constant. The equilibrium constant for the reaction is the reaction is mentioned P4, the mention as solid, then plus 5O2, that is mentioned as gas, then P4O10, that is mentioned as solid. Clear? Right. So options are mentioned. Look at the options. Then Kc equals to square root of 5 into O2. Then Kc, it is equals to P4O10 divided by P4 into O to the power 5. That is option B. Then option C, they are mentioned Kc equals to O2 whole to the power 5. Then option D, Kc equals to 1 divided by O2 whole to the power 5. So look at my dear students. So look at the question carefully. Sir, equilibrium constant for the reaction is. So actually the equilibrium constant, how to find out I told. That is Kc equals to product's concentration divided by reactant concentration I told. Yes, product concentration, what will be there? Then P4O10, right? Then divided by, so P4, then O2 whole to the power 5. Yes, all of you. Sir, here you have to observe one of the thing, according to the law of mass action. According to law of mass action, sir, active mass of solids, sir, wherever the solid is mentioned, active mass of solid, that is equals to 1 we have to take. So Kc equals to, this is a solid, right? 1 divided by, even this is also solid, then only O2 whole to the power 5. So that we have to take 1 divided by O2 whole to the power 5. So according to law of mass action, solids concentration or otherwise active mass of solids equals to 1 we have to take. Okay, clear? Yes, note the next question. Note the next question. Note the next question. That is for the reaction. Fourth question. That is for the reaction. H2 plus I2 gives rise to 2HI. Gas, then gas, then gas. Clear? Then for the reaction Kc and Kc relation, they are given the options. Question inte undi. Then Kp equals to Kc not equals to 0. Then option B they are mentioned. Kp is greater than Kc. Then option C is there mentioned. Kc is less than Kp. Kp is less than Kc. Then option D they are mentioned. Kp equals to Kc equals to 0. So these are the options. Look, my dear students, observe the question carefully. Look, my dear students, observe the question carefully. Yes. So here H2 plus I2 gives rise to 2HI. For this delta n value, number of moles of products minus number of moles of reactants, that you can get 0. Already I told wherever the delta n value 0 is there, Kp equals to Kc I told. Kp equals to Kc I told. But Kp, Kc not equals to 0, man. Something value will be there. So not equals to 0. So that is correct answer. Wherever the equals to the 0 is there, that is wrong answer. Don't select such type of answer. Clear all of you? Right? Yes. So come to the next question. Come to the next question. That is question number 5. Question number 5. For the given equilibrium reaction, for the given equilibrium reaction, for the given equilibrium reaction, 2A gives rise to, then 2B plus C. All these are gases. Gas. They're mentioned like this. The equilibrium constant Kc at 1000 Kelvin temperature. 1000 Kelvin temperature is 4 into 10 to the power of minus 4. Calculate the Kp. Calculate the Kp for the reaction. At 800 kelvins. Look at the question carefully. Options not changed. Option A, that is 0.044. Option B, 0.026. Option C, 0.33. Then option D, that is equals to 1. This is the question. Look at the question carefully. Yes, look at the question carefully. So here, for the given equilibrium reaction, so this is the reaction, right? The equilibrium constant Kc is mentioned, that is at 1000 Kelvin temperature, 4 into 10 to the power of minus 4. Then calculate the Kp for the reaction at 800 kelvins. The Kc ichadu, Kp find out chemannadu. So Kp equals to Kc into RT power delta n. For this reaction, in case if you want to find out the delta n equals to number of moles of gaseous products of 3 minus gaseous reactants of 2, then you can get 1. Okay. So delta n value got it is 1. Then Kc value, how much is there, man? So 4 into 10 to the power of minus 4. Clear? R value, that is 0.0821 into temperature 800 kelvins, right? 800 kelvins. So multiply all those things, and once the 2 zeros, when it is cancelled, the point will be shifted to there. Then the approximate, when it is multiply 8 into 8, 64 into 4, then we can get nearly, that is even 10 to the power of minus 4 will be there, right? 10 to the power of minus 4, then you can get it is nearly 0.026. The Kp value 0.026 you can get. So note the question carefully, then we can get the answer. Yes, note down the question one more. So note down the question one more. Based on equilibrium constant, that is relation between the Kc and Kp, relation between Kc and Kp. Yes, look at my dear students. If the equilibrium constant for the reaction, if the equilibrium constant for the reaction 2SO2 plus O2 gives rise to 2SO3. 2SO3 is 64. Is 64 at 500 kelvins. 500 kelvins. Then the equilibrium constant for the reaction, then the equilibrium constant for the reaction SO3 gives rise to then SO2 plus 1 by 2 O2 at the same temperature is then sir options, look at 8, then B 1 by 8, then C 32, then D 1 by 64. Clear? So look my dear students, this is the question. Observe the question carefully. For the equilibrium constant, if the equilibrium constant for the reaction is 64. So the reaction ki 2SO2 plus O2 gives rise to 2SO3. E reaction ki Kc value ichchadu, that is 64. Then the next one more equation is there, that is the reversed equation. SO3 product side, reactant side వచ్చింది. SO3 gives rise to SO2 plus 1 by 2 O2. ఇదే రియాక్షన్ ని రివర్స్ రాసి దాన్ని 1 by 2 తో మల్టిప్లై చేశాడు. టోటల్ ఈక్వేషన్ ని 1 by 2 తో మల్టిప్లై చేస్తే దెన్ 1 by 2 తో మల్టిప్లై చేస్తే ఏమొచ్చింది? 2 2 క్యాన్సిల్ అయిపోయింది. సార్ 1 SO2, రైట్, 1 SO2, దెన్ 1 by 2 O2, 1 by 2 O2, దెన్ so 2 2 cancel, 1 SO3, yes, and SO3. So now Kc for this, how to find out? I told sir 1 divided by 64. ఎప్పుడైతే రివర్స్ రాశారో ఈక్వేషన్ ని 1 divided by 64, then multiply with what? 1 by 2. When it is multiply with 1 by 2, the power you have to take it as 1 by 2. 1 by 2. So then Kc it is equals to then 1 divided by 8 to the power, if you take, that is 64, right? Then sir, in case if you take 1 by 2 to cancel, then 1 by 8. So answer is Kc value, answer is 1 by 8. So these are the questions they're asking in the previous examinations. In the KCET and JEE Mains and EAPCET examinations, these are the questions they are given. So better to read all these questions and do it yourself once, then So every day at 7 to 8 o'clock, my live classes will be there based on previous year questions. So once observe the questions, note down. Thank you.